Hey guys, I miss you. I hope you guys are doing well and adjusting to this craziness that we're all experiencing right now. Hopefully, the beginning of your week with the online learning has been going well. I thought I would actually change it up a little bit for us, though. I know it's probably not too engaging to have to watch a screen with just my voice going. So I thought this week I would try to screencast it instead. So while you guys are taking notes, you also get to see my face up there in the corner. So it's like I'm right there with you. So this is going to be great. So we'll see how this goes. But again, I'm going to ask you guys to follow along. I would take out your notebook, take out a pencil, calculator as well. That way you have some examples that you guys can go back and look at later. So today, let's go ahead. We'll start. We're going to take a look at 10.4, which is our next section with quadratics. And I just want to clarify a couple things. So hopefully, like I said, seeing me up here in the corner will make it a little bit more engaging as if we were together in class, which I know for most of us is where we would rather be anyway. So let's go. All right, guys, take out that notebook. So I'm going to go ahead and add this into our table of contents. As you guys can see, it's been a little bit since we have. What you guys should have taken a look at prior to looking at this video, though, is we did do 10.1 through 10.3, and that was our graphing of the quadratics. So graphing quadratics. I left you guys that excellent video last week on 10.6, which was our quadratic formula. And then today we're going to take a look at another method to solve our quadratics, which is 10.4, and that's going to be using what's called the square root method. So square root method. Perfect. So let's go ahead and we will take a look at this together. All right, guys. So where we left off last time, though, was we were talking about the different ways that we could solve a quadratic. So with chapter 9, our big focus here was factoring. And so that's, again, when we took our problem and then we used that kind of X method that looked like that. And then we were trying to figure out what two numbers multiplied to this, but then added to this. All right. After that, you guys should have taken a look at graphing. And so graphing, again, is going to be your fallback method. That's the method that you're going to use in case you don't remember how to factor. Maybe you're having a hard time factoring, because it is going to work for every problem. Again, the only flaw to that is that it does take a little bit of time, as you guys have seen. And then it doesn't always give you exact answers. And so that's something that we want to consider too. All right. Our last method that I showed you guys was quadratic formula, which again is going to work for everything. And that's kind of the benefit of quadratic formula, is that no matter what, you can plug it into that formula as long as you know that catchy song. And then it will give you the answer. And as you guys saw, some of your answers were decimals. And that's because, again, quadratic formula is going to give you the exact answer or the exact solution to that problem. And so again, it is helpful to know those different methods. All right, but today we're going to go ahead and take a look at another method that might be suitable for some of you. So let's go ahead and do that. This is going to be 10.4, like I said, and this is our square root method. All right, and so let's go ahead and we'll start with an example. Let's go ahead and we're going to look at a problem that is difference of squares, if you guys remember that. So difference of squares would be something like this. So it's two terms. It was subtracting, and then what made it unique was that both of those terms are going to be perfect squares, meaning that 4x squared we could take the square root of, but then also 25 here we could take the square root of. All right, when we factored something like this, and again we knew to solve because it was equal to 0, our difference of squares was two terms, We would take the square root of the first one. So the square root of 4x squared would be 2x and 2x. We would take the square root of the 25, which would be 5 and 5. But again, remember what made it unique was because we did not have a middle term. We used opposite signs because those signs would cancel each other out at some point. All right, and then from there what we did was we solved it. We said, okay, 2x minus 5 is equal to 0, and we solved for x. So x was equal to 5 over 2. And then we would do the same on the other side. 2x plus 5 is equal to 0. In this case, x would be equal to negative 5 over 2. But again, you would see that you would have these two answers here, again, opposite in signs. So why I actually wanted to start you guys off with this problem though is because you could also use our new square root method to solve this problem. So I'm going to go ahead and write that same example. 4x squared minus 25 is equal to 0. All right, and with the square root method, what you're doing is you're actually just solving. You would solve it just like you would any other equation. So just like we did before, the goal is to get x by itself. So our first step to get x by itself, remember x does not move. We're going to go ahead and move over this negative 25 by doing the opposite. So add 25 to both sides. This cancels. You would have 4x squared is equal to 25. All right, to get x by itself, we're going to go ahead and divide by 4. And so now we're left with x squared is equal to 25 over 4. All right, remember, goal is to solve for x. So to undo that square that is right here, we would have to use our square root method. So square root both sides, and you're going to square root the whole entire fraction here. You would be left with x is equal to, so square root of 25 on the top is going to be 5. So remember, we're square rooting the top, but you are also square rooting the bottom here. So the square root of 4 would be 2. Now, what I want to remind you and what I want to point out though is when we factored it, notice here on this side, we had two answers. We have the positive answer and the negative answer. When you take the square root of something like we're doing here, you're also going to show that it has two answers. So you're going to put a positive and a negative. And that's going to ensure that we have, again, two answers. You're taking the positive square root of it and the negative. And what I mean when I say that is, for example, the square root of 25 we know is 5 times 5. But also think, the square root of 25 could be negative 5 times negative 5, right? Because negative 5 times negative 5 is still going to give me positive 25. And so again, that's why when we do take the square root of something, we want to remember that there are two answers. So for this entire section today, you do want to make sure that you are using, again, two answers. And you'll see that a lot with that plus and minus sign. So that is how you're going to notate it. So watch for that. So let's go ahead and try a couple other examples. I'll show you where that plus or minus comes in again. And again, that's because when we take the square root, it could be either positive 5 times positive 5 is 25, or it could be that negative. Negative 5 times negative 5 still equals a positive. So again, look for two answers. Okay. Now, before we look at another example, what I want to remind you are a couple of things about the square root method is that it works when you have this form. A squared plus C is equal to 0, or in this case, some sort of number. So again, it's A squared and C. You're not going to have that middle term of BX. So again, it's just squared and a number. All right, the other thing you want to remember with your square root method is that you are going to be looking for two answers. And again, it's because you're going to have that plus and minus when you take the square root of something. All right, so let's go ahead and we'll look at another example. Here we go. All right, let's say we have this. We have 3x squared minus 11 is equal to 7. All right, and so here again was what I was talking about. You're going to have an x squared term, and you're going to have a numbered term. And so that's when you can use your square root method. Essentially what you're going to be doing again is you're going to just be solving for x. So I will write that down too. So solve for x. All right, so on a problem like this, again, goal is to isolate x here. So I'm going to go ahead and add 11 to both sides. This is going to cancel. I would have 3x squared is equal to 18. Again, isolate x, so I'm going to divide by 3 on both sides. So what I'm going to be left with here is x squared is equal to is equal to 6. All right, and then your last step here though again is going to be to get rid of that square. And to do that, you're going to take the square root of both sides. So you're going to get x is equal to, and this is what I want to remind you though, is anytime you take that square root, you want to make sure that you are giving a plus and a minus answer. So you're going to have x is equal to positive and negative square root of 6. And then for this lesson, what you want to do though is you are going to want to round. So you are probably going to need a calculator to do that. I'm going to go ahead and plug this one in. Square root of 6 is about 2.45. So in your answer, indicate that. X is about positive and negative, because there's 2 answers, 2.45. And so that's how you would write your answer for these problems. All right, hopefully that made sense. Let's go ahead and we'll take a look at maybe a couple more examples just so you have an idea. And I do think that should be enough to get you guys through the homework for this week. All right, let's go ahead and look at something like this. All right, let's say we have 6 times x minus 4 squared is equal to 42. Okay, so when you see a problem like this, there's actually a couple of things you could do. You could take this problem here and you could expand it and you can solve. So you might do x minus 4 times x minus 4. Multiply that, multiply by 6 is equal to 42. And you will get an answer. However, I'm going to tell you guys that is extra steps that you don't have to take. So your goal on a problem like this, just like we did here, is going to be to isolate the x squared or isolate the squared term. So same thing here. So again, goal is to isolate the squared term. All right, and so what I want you to do is think of it like this. Even though there is that parenthesis set here, think if this was 6 times x squared is equal to 42. To get this x squared by itself, I think a lot of you guys could probably see that your first step here then would be to divide by 6. Divide by 6. And so we're actually going to do the same thing here. So again, because the goal is to isolate the square term, so get the parentheses with the square by itself, we're going to go ahead and we're going to divide by 6 on both sides. So the 6 cancel. And so what that leaves me then is this x minus 4, and again squared, so the whole thing is in that parentheses, is equal to, and then again you would have to do some math or figure that out quickly in your head. You would get 7 here. All right, and now you're going to solve. Now, what I'm going to point out to you guys though again is notice that this whole thing is squared. our goal is to isolate x. So kind of think of it like this. X is in this jail right now. X is in square jail. We have to break him out of square jail. And so to undo that square, we would square root both sides. So that would be your next step. So square rooting both sides gets rid of that square, because remember, they cancel each other out. So this and this cancel each other out. That leaves me now with just the parenthesis. X minus 4 is equal to the square root of 7. And there again, we took the square root. So you want to remember that there are going to be those two answers though. So you should have a positive and a negative here. So always remember 2 answers. I'm going to go ahead and highlight that. All right. Now, again, goal is to isolate x. So remember, the goal is solve for x. Okay. So here, if I was solving this problem, my last step then to get x by itself would be to add 4. So we would have x is equal to this 4, and then plus or minus this square root of 7. Now, an answer like this is called radical form, where you're going to leave it inside of the square root. But what I want you guys to do is to solve, meaning calculate that. So again, grab that calculator, and then you're going to go ahead and do a little bit of calculation. So when I'm solving this problem, I'm going to have 4 plus or minus square root of 7 here is going to become 2.65. And I'm going to go ahead and round to the nearest hundredth. And what I will remind you is that there's actually 2 problems here. So you have 4 plus the 2.65. But then you also have the minus part. So you're going to have 4 minus 2.65. And so then you're going to calculate both of those here. So first one then, answer is going to be 6.65. And then your second one here is going to be 4 minus 2.65. You're going to get 1.35 as your answer here. Okay, and so again, that's using your square root method and isolating the squared term, the parenthesis, and then breaking out that x from that parenthesis or that squared jail, and then solving for x. So again, those are your 2 answers. I'm going to go ahead and do one more example if you guys want to follow along if that did not make sense, or if you want to make sure this makes sense to you before you do the homework. If not, you guys can go ahead and fast forward to the end of this video as well. But I will do one final example just to make sure that made sense. So here we go, last example. 21 is equal to 3 times 2x plus 14 squared. Okay, and so again, first goal is going to be to isolate this entire squared term. And so if it helps, think of it as if that parenthesis were an x. For example, 21 is equal to 3 times x squared. Hopefully you guys would say to get x by itself, we would have to divide by 3. So that concept is the same here. To get that parenthesis by itself here, we're going to go ahead and divide everything by 3. So that way the 3's cancel. Now you're going to be left with 7 is equal to the parenthesis, 2x plus 14 squared. All right, now remember, the goal is to help this x break out of that squared jail. So to get them out of that jail, we have to undo the square here. And to undo the square, that's again where we're going to take the square root. So I'm going to square root this side because square root and square cancel. And remember, if I do it to one side, I'm going to make sure to do it to the other side. So that's why I'm taking the square root on this side. All right, square root cancel. I'm left with then just the parenthesis, the 2x plus 14 on this side is equal to, again, took the square root, so we're looking for 2 answers, that plus or minus square root of 7 here. All right, and now last step is going to be to solve for x here. So to get x by itself, which is right here, first thing I'm going to do is subtract 14 from both sides. So plus or minus square root of 7 minus 14. And notice that I didn't combine them here. So because of that square root, I'm just actually going to leave it as is before I solve it. So it's the square root of 7 and then it's minus 14 is going to be equal to 2. All right, my last step here then would be to get this x by itself. And so to do that, I'm going to have to divide by 2. So I'm going to divide everything here by 2. All right, and let's go ahead and take a look then at what this looks like when we solve this. So I have the positive and negative square root of 7 minus the 14, and this is all divided by 2. All right, what I'm going to remind you guys is that this is actually two problems. So similar to when we did inequalities and how to split it, same thing. So I'm going to take the positive square root of 7, and again, you're going to have to probably calculate it at that. So that's going to be positive 2.65, and then minus 14, and then divide all that by 2. So what I would do is I would simplify just that top part first though. So 2.65 minus 14. And that would give me negative 11.35. And then now divide that problem by 2. So this gives me an answer of negative 5.675. And then again, I would do the same on the other side, but I'm going to take the negative of this one though. So this is going to be negative square root of 7. So negative 2.65 minus the 14. And then again, all over 2. Same concept here. Simplify just the top part, so that numerator first. So 2.65 negative minus 14 is going to give you negative 16.65. And then divide all that by 2. And so when you solve that here, you're going to get negative 8.325. And those would be our two answers here. So again, what you'll notice about a problem like this is that these two final answers would probably not be something that you guys would see on a graph just because they are very exact or very precise numbers. Same thing with factoring as well. So that's why at times it does help to know these different methods. So like I said, as long as you see this squared term here, oops, so that squared term here, or like we saw in our problems here where it was just x squared, that's going to be kind of your clue that you can use that square root method and that you can just solve for x to kind of speed that up a little bit. I will tell you your quadratic formula also works here too. It might be a little bit lengthy in steps, but it does work in a problem like this. For example, if you had this one, 3x squared minus 11 is equal to 7. If you were to set this equal to 0, you could subtract 7 on both sides. 3x squared minus 18 is equal to 0. In this case, you would have 3x squared plus 0x minus 18. And so you could plug that into the quadratic formula. If you guys are looking right here, you can notice that 3 and 18 have that factor of 3, so you could also factor. So like I said, a lot of your methods are going to be able to use kind of interchangeably, but it is good to just have that knowledge of how to do the different ones. So hopefully that helped. Hopefully it was more engaging to see my face up here. All right, guys, what do you think? Was it better? Let me know down below. All right, in all seriousness though, hopefully the lessons are making sense and the material is something that you guys are understanding right now. But in the case that it's not, please go ahead and send me an email, and then remember, check into the Zooms on Tuesdays and Thursdays, and then that way we can go over the material that we cover also in the YouTube videos. If you do need additional help on Friday, I'm also available, but remember to email me first. That way we can set up a Zoom if necessary. All right, guys, stay busy, stay safe. Please remember that I do miss you guys, and I do wish that we were in class instead of this. But I will see you guys next week. All right. Bye, guys.